Hey, thanks for checking out our video for our CIS 111B project. We made a connect4 game that uses a reinforcement learning algorithm and a deep Q neural network to sort of teach itself or learn how to play connect4. And it didn't look quite like this, but let's check out and let's see what we did. This is the main method. This is the main training method that we use to train the model. Here, this is our QL configuration. These are the hyperparameters, I should say. We ran it for 500,000 iterations. And down here, some more parameters like the regularization rate, the learning rate, which is probably the most important parameter to play around with. 42 nodes in the network, one for each unit in the array, and three layers deep. And we save a training file. We feed it a Markov decision process that we set up that contains, that references the board environment and contains all the methods to kind of step through playing the game and returning new states. And then we train it, and then we get the final policy and we save it into a file. So let's run it real quick here. We'll just take a look. Just going to scan through all of its files. We use the Deep Learning for J framework, and it has some limitations, but it's in Java. We're pretty happy with it. It has an active community. And so there it goes. So it's running through these epochs. Those are complete games played, and it gives a reward at the end of each game. So positive if the model wins, and negative if the algorithm, the solver algorithm, wins. Ian's going to explain a little bit more about that in his part. And so we can go ahead and stop it there. It starts off easy. The solver starts off easy and then kind of scales up a few steps as it gets going. So we're going to stop it, and let's run the full one, or our saved one. It took about 40 minutes to run through 500 iterations on my computer. Let's go scan again. This is our console interface that we have. Okay, so it moved in 5. The network's going to be... Nope, it didn't block me, so I'll take the win. So it's not very good, but by the end of the training, it was against the algorithm that we had training against it. It was winning about half to 2/3 of the number of times by the end of there. Obviously, it's still not very good versus a human. I can still beat it, so I can still feel pretty good about myself.
So while researching for an algorithm that can solve connect4 in GitHub, I found multiple different instances, but none of them ever really came to fruition because it either had some sort of input-output problem or required several different libraries that just didn't seem compatible. However, I actually found a link to a connect4 algorithm by an author, Raul Gonzalez, who created basically a min-max algorithm that's very simple input-output, and it works through 4 main classes. You have a main class, a gameplay class, which essentially defines some of the rules and move making, and then the min-max class, which is the actual algorithm that basically solves the move for the computer. And the final one is state, which essentially just basically provided the board and general state rules. We actually covered the state portion in the connect4 board that we created. However, the min-max and I/O from main provided essentially the most useful input-output connections. Because with the I/O here, I was actually able to implement Joey's hardware connect, so that way we could essentially play a game versus the algorithm through Joey's board. And this I/O actually made it a lot easier for Dennis to implement his trainer method. So essentially, these 4 classes from GitHub by Raul Gonzalez made our portion of the neural network a lot easier.
So the main Java program will use hardware_connect.java as a way to communicate between itself and the Arduino here. Then the Arduino can take the data that is received, and by controlling these 2 relays here, this relay for on and off and this relay for direction, it can control this motor back here, which makes this mechanism move back and forth. Once it's in the right spot, it can use this servo here to turn the dispensing wheel inside and dispense a token. So when the chip is dispensed, it'll create a shadow which these photoresistors here will pick up and detect, which causes them to change the resistance, and the Arduino will detect this, and based on which photosensor it is, can figure out what column the chip was. Now what's really nice about the main part of the dispenser is that it fits together like a giant puzzle. So this piece can come off, and then you can see this piece comes loose, this piece can slide out here, which makes it very easy for taking it apart and moving it. So you can just disassemble it like a giant 3D puzzle.